All right, I'm going live here. Sorry for the delay in getting started. If for those of you who are following along on the chat, I had to do some updates on my C-Line config, so hopefully you can hear me. Everything is looking good at the moment. And I have my Compiler Explorer mug back out for some tea today. That's always a nice one. I know that there's going to be a 15-second delay or something like that, so just I'll try to pay attention to the live chat when I can. But the goal for today is to apply some more constexpr action here to our CPP, C++ Doom port. Now, I'm still in the crispy Doom folder. I was just looking around and checking to make sure that I had the right thing built here. So I built it, and I am proving that it is in fact linking to lib_std++. So we have some degree of confidence that this is the C++ version of the build. I'm getting a warning from YouTube here that I'm not streaming enough data, so I'm gonna see what's going on with that. I don't know why. Not receiving enough video to maintain smooth streaming. As such, viewers will experience buffering. I have no idea why that would be the case, but I'm gonna shut down a few more things on my side just in case I am doing something that could affect it. Alright, I'm gonna just keep going with this. I'm gonna see if this is taking up too much of my CPU. Well, okay, that might have something to do with it. It looks like JetBrains, it looks like C-Line here has got a lot of indexing to do, but it should be done in a minute. Alright, sorry about that. Now, where are we? We did a 13-hour port, for those of you who want an update. We did a 13-hour port of Doom from C to C++, and mostly this involved lots of casts, because C++ is much more strict about typing than C is. So we did a bunch of cast, and every now and then, here and there, we had a couple of wins. We had a couple of things where we were able to swap a malloc and free with a simple unique pointer, or a rather complicated vector-like thing with standard vector. So we did what we could, where we could, when we could do it. Now, today, I do want to have a very specific goal of one particular part of this code that I want to make constexpr. And, you know, I spent 13 hours, more than that, just completely underwater in this thing. And I cannot remember where that file was. So I'm going to go look for that now. So it was all of these event functions. We had all these functions, a light, 0, a weapon ready, a lower, just dozens and dozens of these things. And yeah, I'm using NeoVim mixed with C-Line at the moment because I'm just feeling that way at the moment. So a light 0. A light 0. Let's make sure we're in the right project. We are. One problem that we had during the live stream is we kept accidentally jumping over to the Hexen and Heretic versions of these things. But we've got this table here. Let's see, that's one of them. This is the code pointer table, which is a static const array. Now, this is all information that is known at compile time. It is const character pointers, and it is function pointers. This action ft we spent a fair bit of time on this thing, is this union of a bunch of different function pointer types. Sorry, Ollie, it seems that you're getting your messages deleted. I don't see, is my Streamlabs bot, has it been posting the information here? I don't see that my Streamlabs bot is posting what it should be posting. That's annoying. I'm trying to get my streaming set up better each time, so sorry about this. Yeah, I'm not gonna risk messing with anything at the moment. But yeah, so the Streamlabs bot is pretty strict about some of these things to make sure that we don't get any spam on here. So emojis are not allowed, and I am using sea lion. Okay, so this action FT, let's go see where that is used. Action FT. Oops. I am using it in the DEH pointer.cpp. And where else am I using it? That's Strife. Okay. So that's Doom, Strife are the main things that are using an object called this. So this is my goal. I want to make this object constexpr. I want to start with this one. There's going to be others. There's other large tables. Let's start with this one though, because this is the one that caused us so much pain the other day. Now, how do I want to do this? I need a code pointer table and a new header file because we need the ability to be able to include this in multiple places. That's what we want to do. Oh, no, wait a minute. This is actually only used in one place. So this should be relatively straightforward. I feel slightly confused by that because I swear that we had to hit this up in multiple places. I need to do some more research real quick. I had a specific idea, but maybe I don't know what I'm doing. But if you were here for the 13-hour stream, that shouldn't be terribly surprising. Let's go into this action FT again. Where does this thing live? I want to see where ACP1 is called from. Doom mcrispy.cbp. Ceiling arrow thinker.function ACP1. It's the kind of thing, where is this? Ah, that's a reinterpret cast in the middle of our Doom source code. All right. Where is that coming from? Okay. What is thinker T? How do we want to go about this? All right. Let's just start by making this thing constexpr, and I've been giving a lot of thought to this. At the moment, this is a union of 4 different function pointer types, which is a bit of a lie, because if you recall from the stream, if you were here for it, we had something like 5 actual different function pointer types. Is there going to be any performance benchmarking compared to C at the moment? No. That'll be later. Oh, there's Streamlabs coming in. All emojis are banned and the IDE is sea lion. Yes, so the goal is to move as much as possible to compile time eventually. So let's see, we want this thing to be constexpr capable. Constexpr. Let's start with the simple option. Give it some constexpr constructors. Constexpr union. Let's just see what happens if we do that. If I make this a static constexpr, array. I need to change my target to C++ Doom. That's the official name of the binary now, by the way, C++ Doom. Oh, alright. So, we made that constexpr. Yay! That wasn't a big win. What was it yet? So this is a Bex code pointer T array. Oops. Now, I don't expect that this minor change here to make any real difference, but I do want to make this an array. Now, actually, what compile mode did I put this in last? So let's... C++ 20. We have to try this. We do. So that is a regular C-style array. Just out of curiosity. Bex code pointer table. No? Let's open up as a web browser here. Oh, by the way, it says my stream is healthy again. So that's something. Yes, I'm on Manjaro Linux. Although Firefox is slowing things down a whole lot right now. ToArray takes a C-style array, since C++ 20 is constexpr, and it is in the array header. Looks like I did that right, but it looks like our standard library does not yet have this feature. We're just going to leave this as a C-style array at the moment. Isn't standard array lookup slow? No, standard array lookup is going to be at least as fast as a C-style array. It should never be slower. Standard array is just a stack of, it's just a bunch of objects on the stack right where things live. Yeah, standard array, same performance, at least. It is, in some cases, a negative cost abstraction because the compiler has more information depending on the context because it knows the size. The size is encoded in the type. So the reason now why I'm sitting here going, I really want to make this a standard array, but I haven't yet. The reason why not is because how many items are in this list? Okay, that's 125. I have selected 89 lines. All right, so I could do it like this. No, what is the name of the table? I just deleted it. Why did I do that? X code pointer table. Now, the problem with doing this is it appears to work. Yeah, it's just harder to work with in a large table like this because I don't know the exact size of it here. And then I have the types to deal with for each of these things, so I would need to kind of wrap each one of these lines in this. Well, I could, and then I could do that. Make an explicit instantiation of things. Anyhow, this becomes messy. I want it to be a C++ standard array, but I don't feel like dealing with it at the moment, so I'm just going to go back to this. So we made that constexpr. That just made the whole thing look easy. Let's just go ahead and go home now, I think. We're done. No, let's look for the other uses of these guys, which really had me yeah. So these all load without any problem. But I know that we had places where we had to cast with this ACV, ACP1, and all these things. So what I'm going to do is start changing this around a little bit. Now, if I make it a struct instead of a union, I don't have the possibility of accidentally accessing the wrong member. We'll get now a real crash if we try to do that instead of an implicit cast. So we're going to try to reduce some of our possibility for undefined behavior here. Now, I don't know, this probably end up going to be a mistake, but I want to try it because I really want to understand how and where this data is used. Okay, so this should still let this compile. No, ActionFT definitely should not be a variant. Whoever said that was not with me in hour 11. We tried to make it a variant. I spent at least an hour working on it. It was the overhead of trying to access the data in it, both syntactically and potential runtime overhead. It was just not the right solution. Array size can be deduced in C++17, yes, but array type was what my problem is here, and that's why I didn't go down that road at the moment. Yeah, yeah, okay. Let's do this also, as long as we're talking about constexpr things. We're going to make it a string view mnemonic. And I just intentionally hid these. I'm going to make a build, and I'm going to see where exactly this ACP1, ACV stuff is used. Well, I no longer need that line because it's going to be initialized to null no matter what. So that's something. Unused include. Okay. No, don't care about that. Yeah, we want to avoid vector. We want all of these things to be known at compile time as much as possible. Oh, those are warnings that we're well aware of. Okay. If this dot function ACP1 is a private member of action FT, yes, we know that. So we're doing these kinds of things here. This is what I really want to fix because we're doing these. I don't even know how it could have become a p mob thinker. Let's find where that thing is referenced. Apparently, some of these data bits are swapped out at runtime. These actions here. mObject, thinker, function. So it's whatever thinker thing is applied to the object at hand. And then this is the thinker. And the thinker takes an mObject. So this should not even be necessary. Why did that fail to compile now? Those of you who were here and remember the pain of searching for all of these function names to figure out what their exact type should be. This is the kind of thing that I really wanted to focus on. I wanted to figure this out. So here it's declared correctly without a void pointer. Where's the definition of the void pointer? Where's the definition with the void pointer? Oh, come on now. Oh. Action FP1. What? What just happened? I was down in the Strife source code again. Dadgummit. Hate it when that happens and I'm not paying attention. Alright. This is the errors that we're expecting here because this thing is private now. And we did that on purpose to call attention to where they are. Really want to track down all the potential cases of undefined behavior and how this thing is used throughout the code base, since I spent so much effort messing with it 2 weeks ago. Oh, and I saw an earlier comment from someone saying, hey, did you miss Stream 4? Stream 4 was a transient thing. I did it just for just a few minutes, an hour 1 week ago, and I did not put the recording up for everyone to watch. I just didn't. So here we are. Oops. I'm in Doom. I can do this, and I should be able to get rid of that. Oh. No, that's not going to work. Yay, references to pointers. Now we're really going to understand how this code is used. Alright. T move ceiling assigning to... Aha! So this is where we were getting one part of our undefined behavior from before, is we were shoving these things into things that expect an mobj t, and instead they need a ceiling t. Excellent. I think I'm straying from the original goal of constexpr, but this is definitely the object that I wanted to clean up. It's the one I wanted to start with. So here we are. I probably should set up cline to ignore the strife and heretic stuff. I should just compile it out. Is it an optimization stream? No, it's just a spending time with C++ stream. No, this is a game called Doom. It's not a virtual machine. Yes, I'm using the built-in Vim plugin. It comes with it. It's Idea Vim. It's down here. All of JetBrains products have it. All right, so let's see how we can straighten this out a little bit. So we want a new type that can take a, what was it? Ceiling T? I really want to understand how this code is used. I really do. Ceiling T. Ceiling T. Whatever. I think this is going to end up making sense. Here's open. I know there's a couple of people who said that this stream 2 weeks ago was like having a coworker in their office, so I hope at least some people get some something from having this on. Whatever. The type system is going to keep me under control here. And at some point, yes, maybe we should move it to a variant, but again, I want to understand how it's used more. And hopefully we'll be able to do that. No, let's do void here. Let's keep it canonical. Assignment operator. And I want it to take an object of type action fc1. This is our function pointer. And I will say, There, and equals assignment operator. Can I do that? I'm getting all kinds of errors now. Member access incompatible into incompatible type ceiling T. What? Oh. Hopefully this won't be a giant waste of time. Incomplete type ceiling T. Or did I just declare ceiling T? Did I spell it wrong? Yes, I did spell it wrong. Y'all should have told me that. You probably did. Yep, you did. All right. Which means, did I spell it wrong over here too? No, I didn't. Okay. Okay. Oh no, I'm not gonna. I don't think I want to do a big find replace call to that, John. Not yet. I want to understand how it's being used. I definitely want to understand how it's being used. I don't know. So yeah, because I want to be able to like see this. I need to know, what is this? This is just an imobj. Okay, so this one is safe to do. Now, okay. All right. Let's go ahead and let's keep trying to make this type easier to use. And again, this is the kind of thing I've actually literally been keeping me up at night, off and on for the last 2 weeks, while I've been thinking, how could I have done parts of this better? And I spent so let's just like look at this. Where did that last one go? Oh, whatever. We'll come back to this. So if I've been given one of these, then I want to return if ACP1 is equal to this. Make sure you make this thing const and constexpr ACP1 action FP1 return expected. There is a semicolon at the end of the declaration. I think C-Line's thing is running a little slow here. Oh, that's weird. Can you still hear me fine? Oh, there is a hanging brace. I've never had a problem with my webcam. That is very strange. Huh. All right, I'm just going to turn off the webcam. Yeah, all right. I'm turning off the webcam. It's not worth it. All right, that was a missing brace. Fine. Okay, we fixed that. All right. Yeah, see, this is brilliant. We need to know how this stuff's being used, right? How and where is this being used? What is the ACV action? Does it actually exist? I don't think it does. I don't think we're... Are we? This is casting it to... Oh. a C-style cast to avoid pointer, which is undefined behavior in C++. Well, it's not undefined behavior. It is implementation specified behavior. All right, so let's see how this cast action is used. If the cast action is null, wait, let's make sure that we're in the right file. Yes, we're in Doom. If the cast action is null, then whatever. Otherwise, if the cast action equals whatever this other action is, and the next action equals whatever this other action is, then use this as a sound. Okay, so we're not actually using the ACV here. We just need a convenient way of getting back a comparison and say, is this action object equal to this other action object? That's really what we want. So let's do this. Let's just copy the action object. Distill this down to the essence of what this is. Copying this action object is not expensive. Oops, I missed a paren. There we go. So I need to know if the cast action is null. Surprised that's compiling. Surely that can't compile. Oh, we'll deal with that in just a moment. So that's an action FT. Yeah, that's an action F treat. That is an object, not a pointer. Okay. Invalid operands of type cast action FT and cast action F. Okay. Can I do that? Camera died. Sorry. Overloaded operator, blah, 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 must be binary. Okay. Defaulted three-way comparison operator must be const qualified. Neat. Ha 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 ha. No conversion. Invalid operands. Let's just do this and see if it gives us what we want. Okay, neat. All right, so, all right, that's good. So we're actually using the three-way comparison stuff that was added in C++20. The inline blame is an extra plugin here. It is what is it? It's plugins. Installed. It's this one, Git Toolbox. Yes, Git Toolbox. All right. Now, this is failing because we're doing string comparison with our string view, which is fine. String case compare. Compares S1 and S2, ignoring case. Now, why are we doing a ignore case comparison here? That seems frustrating to me, shall we say. Now, I can just get around this. No, that's right. This is not guaranteed to be a null terminated string in here because I made it a string view. Let's get rid of the string view so that we don't get too distracted with too many things at once. That was back in, that's in here. I'm just going to put this back to a const char star for right now. That'll be something for the future. For whoever it was who asked if it's compiling it, yes, we do have it compiling and running, but we are doing some betterification of the code as much as we can. So it's an action fp1, that's a mob obj. T. T fire flicker takes a flick pointer. We're gonna see if this ends up making any sense at all. I think it probably does, because at the very least we're removing undefined behavior, and removing undefined behavior is rarely a bad idea. Now, at some point, it's going to end up becoming clear that this is actually a probably something that should have a class hierarchy representing it. But the compiler is going to catch us all along the way where we make any type errors. I have no idea what I'm getting myself into. All right, that's a ceiling. We're dealing with ceiling objects already, so I can do that. Yes, it's the kind of thing we want to see. And this one is Anyone else notice this? It's probably in the stream, wasn't it? Yes, a const char array has to be null terminated. Well, no, that's not entirely true. A const character array can be anything you want it to be. A const character pointer, which is generated as a compile time generated thing, must be. Why no emoji? Because you should have been here during the last stream. Yeah. So this stuff is compiling because I did not make this I did not make these explicit. I really don't want implicit conversions coming in right now while I'm trying to understand how this code is being used and how much of it we can move to compile time constants. Aha! This is the other chunk of data that I wanted to move to constexpr. And I just found it by making all of that explicit. Look at this. Look at this. Can we make this constexpr? I really want to make this constexpr if I can. This is ridiculous. This thing is huge. This is where things are going to get exciting. For sure. Oh my goodness. All right. That is state T object, and this is states. Oh, so fascinating. I'm going to pull these back out again. I want to see what happens if I make this const. Let's forget about constexpr. What happens if I make it const? Okay. Where's the previous definition? It's an info.hpp. Okay. All right, let's see what happens. La, 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 la. Can you imagine if we can make this all a compile time constant? What kind of effect it could potentially have on the code? This is huge. This is huge. Let's see what happens. Oh, I'm going to regret this. Yeah, I am. So much stuff in here. Okay. It says that the states is not currently used. I'm going to try to turn my head back on, by the way, and see. Nope, that's still frozen. What in the world? Nope, not working. All right. Remember to make states inline to avoid ODR violations. Yes, I'm going to make it inline. See? All right, I cannot get the camera working. I'm not sure why. All right, this is what I needed to know. State equals states. No? All right. Oops. Oh, shoot. There we go. Initialize extra dehacked states. Dehacked states. Dehacked. Does anyone know what dehacked is? I know what dehacked is. I know what dehacked is because I read the Masters of Doom book. And this is actually, I expected this to come up to some extent. Let's go ahead and look up dehacked. It's a modding tool for Doom. This is a tool that lets you go in and change various aspects of the game. So one of the things that you could do with Doom was you could create your own mods. You could create your own, or WADs, that is, not mods. You could create your own WADs, which had your own maps and your own levels and your own graphics in them, but you could not change the fundamental nature of the game. So this tool came out, Dehacked, that would let you go in and actually tweak some of the values in the core engine. And by making this stuff constexpr, there's no way that it would be possible to make this stuff dehacked available anyhow. So I'm tempted to comment this out right now because we're trying to deal with the fact that we want to be able to make this thing constexpr. So I'm going to go ahead and comment this dehacked out at the moment. There's probably a keyboard shortcut for this, I know. I'm going to trigger someone. That's fine. Yeah. I wonder if that's what all this DEH stuff is dehacked. Support for dehacked. It is. Action pointer entries in dehacked files. That's what it is. So if I move this to constexpr, I am breaking support for dehacked. Compile time constants are not entirely uneditable during runtime. Ooh. Okay. We will do a little bit of compiler explorer action here. So the classic example I like to use. Not reinterpret cast. All right, so this code, I appear to be signing 10 to this value here at the memory location where I is. The compiler knows that it's a compile time constant. It is going to swap it out with 5. This fact that I am doing a const cast and an assignment to this thing equal to 10 is irrelevant. And you might say, hey, but you're in O3. Okay, fine, I put it in O0. We're going to see this behavior from basically every compiler. The compiler sets up stack space for the variable, it assigns 5 to that memory location, and then it loads the address of the memory location that it just assigned the value to, and then it assigns 10 to that same memory location, and then it returns 5 from main. So yeah, anything that is a compile time constant, we have no guarantee what the compiler is going to do with it at all. You can't, but you don't know where the memory is the problem. You say, oh, clearly you can change where the memory is residing, but no, you can't, because you don't have any way of knowing. The compiler is going to take these compile time constants and place them wherever it wants to throughout the code base. So yeah, I am going to, it looks like, end up having to disable the dehacked things if I want to make more of this constexpr. That is definitely where we are. So how much can I just remove this DEH stuff altogether from the code base? All right, you're saying modern C++ over, that seems to be the vote here. So let's see if I can just remove the DEH code altogether. That seems risky. Seems risky. So that's DEH Bex pointer. Oh, this is the original one that I was updating. Parses code pointer sections and Bex files. What are Bex files? Bex. That's these files. It's the Doomhack files. All right, what happens if we disable it outright? Sorry, I'm getting a little ahead of myself here. I need to see what project they're actually in. They're in the Doom project specifically. Wow, what happened? Oh, ew. No, wrong comment system. I'm gonna get missing symbols somewhere. I don't know where this Doomhack stuff gets integrated into the project. Something's gonna fail now. But now we know what we're looking at. So what is this? Vertical door, door. That uses a VL door T. Streamlabs forbids your hearts. I'm reading all of the comments. So I don't have the comment stream posted on the live video, by the way, partially because of all the spam nonsense that we got last time. I'd rather see a modern C++ optimized version over compatibility, which I still don't get with the C version. Okay, so other people say it's silly to say I'm making a port, but then removing features. I see that as well. I see definitely both arguments here. So, okay. Let's try to not remove the Doomhack stuff at the moment. Oops. Mapping, yeah, okay. All right, we're gonna take this and put that back to there. And we're gonna take the CMake file. I agree with the sentiment. Let's try to not remove features at the moment. Let's see what happens if we keep everything the same as much as we can. So that did that. What else did I mess with here? Oh, I just added that. Okay. We're going to get rid of these. Okay. Now this problem. No, state T. All right, let's. All right, so the problem fundamentally is that I made this const by making it constexpr. Now, there's a lot of other discussion on the chat here about this. So if I make it constant, so constant values must be static. They must be initialized with a compile time constant, but they are not constants. So that is definitely a good use case for this code if we want to maintain the compatibility with the existing code. Now, having moved this into the info.hpp and making it inline, I don't know ultimately if that'll prove to be a good or a bad idea, but then we need to get rid of a couple of these const void pointer here things on the frame start. That doesn't need to be const void pointer here. And we should be kind of back to where we were a moment ago. Yeah, I have to agree. If we want to say any sort of comparison, things got better, faster, slower, whatever, then yeah, we kind of have to leave this in. That's weird. Where did state t get modified to no longer have dehacked? Yeah, did I remove that? There's a better way to do that. I didn't do it today. State t. That's weird. I didn't modify that state. I'm in Doom. I'm compiling Doom. Oh. That was commented out in 2017, and I removed that. Okay, that's still good. Huh. Alright, we're going to try to do this. Oh, right. So this is what I was thinking about just now. You know, I cannot keep my head around the names of any of these things. So that seems like a pretty reasonable way to do that comparison instead of adding a bunch of operator overloads and sticking out of using our explicit T at the moment. I think that should be a pretty optimizable. I'm going to stick with it for the moment. Yeah, what is wrong with operator overloads? I don't know. I'm just thinking like how many operator overloads am I going to have to add? But really it should only be like 5. So you're right. Actually, I didn't even need one in that case. No, wait a minute. I need some way of pinning the action FT header. That's what I need. Where is that thing? Action FT. Think. Can I pin this? I can pin it. Stay right there. I need you around here. Let's go back to putting these things as explicit because we do want to know where implicit conversions are happening. And this finale, a random jump, is a It is an action FP3. Action FP3. Yeah, don't show that again, please. Oh, right. So now we're back to this failing again for obvious reasons. Because I removed the implicit constructors. Cool. Same exact error. Time is that? I've already been going for an hour and a half. Hey. Action FV. No. That's. This is just trying to reset the function. So, FT. There, it's a default value now. All nulled and good. All right. Oh, we did leave off at the vertical door at one point, didn't we? This is a function that makes a VL door T. This is becoming a little silly with these names. I have to give them better names at some point. That is the hardest part of computer science, after all. I really don't care what the types are, honestly. I just need to know what the set of types are and make sure that I can safely compare them. No. V1, VL door T. What just happened? Oh, here. All right. Yep, two hardest problems in computer science: cache invalidation, naming things, and off by one errors. Falcon. Type def, redefinition of different types. You know, I actually am coming to love these because it means that I get to get rid of these type def nonsense that was required back in the day. I'm just going to axe out another one while I'm at it, while we C++ify this. My original plan was to spend about 2 hours on this today. I don't know if that will end up being reasonable or not. Kind of looking like not at the moment. Oh, that's new. Action sounds. Those sound exciting. That works, right? No. Oops. Yeah. Well, anyone want to take any guesses while I painfully do this and you watch me as to whether or not we can make this one constexpr, or if we need to go the const init route because of the DEH stuff? Search and replace get me again. Okay, let's... Oh, it's already static const. I must have done that earlier. Let's make a constexpr. All right. One more thing that we're working towards constexpr. Now we finally get this compile time error, which we should have been expecting. That's okay, because we have a pretty good solution for it now. I just want to say, is it the null action? Very good. I'm all right with that. America has 6 time zones total, I think. Where the time where I am is, it is 11:30 a.m. There's 4 in the continental United States. It was a union. I am removing the union at the moment so that we understand how it's used. Didn't I already make a vertical door? Oh, I didn't make the comparison for it. Ooh, that's my pinned file. Let's just, you know what? Yeah, sure. Whatever. No, I don't want to do that. We're trying to make as much of this code constexpr as possible for those who are just now joining the stream. Why constexpr? Constexpr so that we get more compile time optimization theoretically in the future. Why are we not using variant or a union? This was using a union, but it was incorrect. It was invoking a lot of undefined behavior, so we're getting rid of the union at the moment so that we understand how this code is being used, and then we may perhaps go back to using a union in the future. But at the moment, we're trying to avoid undefined behavior while moving more things towards constexpr when we can. Hope that answered everyone's latent questions here. I'm just going to add a little no discard action in. Can it be replaced by spaceship? I think you still have to have a space. So I'm already using some of the spaceship features right here, just for the record. That's this one. Now, the question is, can I use it for these also? I don't know. If someone looks that up, someone will have to like ping me or something. Yeah, I'm privatizing things. I want to understand what's going on. That is the goal at the moment. We really want to understand what's going on. There's too much undefined behavior in this code, or potential undefined behavior. We're just trying to, We're just trying to narrow it down at the moment. Yes, we know that's not used. Yes, we know that's not used. What is going on? Is that all just... Wait, did it compile? That can't possibly be right. No, okay. Yeah, all right. Yeah, we have a bunch of places in here. Fire flicker. That is a fire flicker T. Yeah, so there's so many types in here that we just couldn't identify before. Now again, it might make sense for these to all be classes in a hierarchy. Therefore, we could make just one version of them. No, that still wouldn't work. Never mind. I'm making crazy talk. Because we would have to deal with covariance. It's its own thing. And at the very least, it'll be an interesting exercise in understanding how the code is implemented a little bit more. Yes. Get rid of another one. Someday I'm going to have to do a search and replace of all the underscore T's somehow. I feel like we can start to have a pretty good idea what the next set of actions are that I'm going to have to implement here. I should have just hit F2. Oh, nope. T flyer flicker. I think I don't know if there's a cleaning tool to kill all the type dist structs in one go, actually. I thought about this. Am I going to get in trouble when T action gets reassigned? I might have to go through and deal with that in a minute. Yeah. Uh-oh. Platform raise. Wonder what kind of thing this takes. It's a plat. Actually, what was it? That's a plat. It is a plat. Where's plat defined? There, it's defined. P-spec. Oops. That's right, I did just yank it. What's really gonna hurt is when we make all of these enum structs. Ew. All right. Oh. I like the idea of just saving it into a macro. Oh my goodness, I did say 2 hours. I don't know how long I'm gonna keep doing this today. That was a struct plat T. And this is, I don't even know what to call these anymore. And none of them are called in the constructor at all. They're all, I don't even know when these things get assigned. That's actually a really interesting question. T plat raise. T plat raise. Okay. We know we're going to have to deal with this eventually. What we're also going to have to deal with is all of these stray tabs in the middle of the code. Some of it's spaces and some of it's tabs. Aye. Anyhow. So this is in the platform code. We know what a platform looks like in Doom. Well, I mean, if you've played the game at all. If you haven't, then you should probably take a minute to play the game so that you know what it looks like, or watch a video of it. This is the original Doom from 1995 or whatever. Whoa. That did not paste in the right spot. Okay. Has anyone done the homework yet to see if if we can use this in a different way with our what was I just looking for? Oh, with spaceship operator spaceship. We will definitely have to play with that at some point, for sure. Looks like my stream is going fine. And I am not going to play. So for those of you who were here for the long stream, it had now in the order of over 100,000 views, which I find really interesting because that is after I made the video. I made the video not public. I made it unlisted. So you had to have a link to it already to be able to see the video. So I made the video unlisted almost immediately because I saw that there was a copyright claim against it because I had these things, the jingles in the middle of my stream for, let's all go to the movies, to the snack bar kind of things from the drive-ins. And that ended up giving me a copyright claim, which I'd say that stung a little bit. Because now over 100,000 views without being able to get any ad revenue from it. It's a little frustrating. But, is a vertical door a different thing again? Oh, we already did that one. Good for us. So it definitely turns out like a lot of this, it seems, cannot be constexpr because in fact the compiler does have to, or the runtime does have to reassign them. Forget the DEH stuff. But making it constexpr isn't going to hurt anything, and I guess we'll remove some unused headers while we're at it. This looks like it's starting to move along again. And I think we're starting to get a pretty good idea for how this is used in the code. What is that? That is a light flash T. That's heretic. Don't go to heretic. That's weird. It's one that I'd preemptively made into a struct a few minutes ago. You probably were already commenting on that on the stream, huh? All right, so I just need light flash T. All right, we're going to start to see where, okay, maybe it does make sense to start to move this into a variant, but I already said it a couple of times. I think we had to get an idea for how this code was used so that we knew that we could. Now, I'm still not 100% sold on the potential for undefined behavior, but it would clean up, or not undefined behavior, but overhead. It would clean up a lot of our use cases here. So simplify a lot of things is what I'm trying to say. Yank, please. Pasting does not work the same way in CLion's Vim integration as it does in NeoVim. I'm always just a little thrown off, or Vim or VI or any of the other VI-like tools that I've used, with whether or not it grabs a new line and what it does with that. But I'm going to compile this. Well, I'm gonna, so to answer your question, King Julian, or your comment here, I am going to hide the complexity in this one class. So everything that uses the class will be clean and readable. And if moving it to variant ultimately simplifies everything else, at least now it'd be really easy for me to swap it out. So I think it makes sense. I am going to take a break. I will be back in a couple of minutes. I am not going to play music during the intermission. I'm back. Just needed a quick little break there. I think we're getting pretty close. We really do. Once I get this round of changes compiling, I'm going to call it a day. Might end up being 3 hours total today. But I really like how this is starting to simplify by using the type system. We're simplifying by using the type system a lot of this code where we'll be able to use operator overloads. We don't have to know exactly which member is in active use and that kind of thing. Now, to answer Josh's comment here, now I'm going to leave this code up here because this is making me cringe a little bit at the moment. To answer Josh Perry's question here, it might fix some ancient bugs, but if it does, it's kind of on accident actually, because this particular version of Doom intentionally has some of the ancient bugs in it. So it's possible that I might fix those in the process of just updating things. Now, why does it intentionally have ancient bugs in it? And that is because they wanted to have 100% compatibility with the very original Doom as it was released. But yes, it is possible that I will catch some of those bugs on accident. Yeah, maybe I should use tuple ultimately. Tuple, templated constructor, and a templated operator equals. I could template the constructor on any function pointer type. Can I assign to that member of the tuple? I could. And then I could do a comparison with that member of the tuple. Yes. I like the idea. I like the idea, Dennis. That's a good idea. No one has anyone commented on this line of code that's here right now? Because I'm not sure what to do with that. The laser spot function action is assigned the value 1. Why? Let's see if I can find that. ACV equals 1 or -1. Oh, come on. Come on now. That's assigned to -1 to 1, but then we're testing for -1 everywhere. Is that a bug that... Oh, fix me. Please have a decent nil function pointer, please. You have got it. That is something I can do all day. We are already there. I am happy to oblige. Don't worry about that in a minute. And look, here's something that relies on an actual null instead of a null-like thing. I probably changed the behavior of something here, didn't I? I probably did. Who thinks I changed the behavior of this? Replace it with plus plus null pointer. Plus plus null pointer should not. Maybe it would compile. Am I in Strife again? Oh, I was. You know what? I think I'm going to leave the Strife code in here just to keep you all entertained. I'm not in Strife right now. That's a ceiling T. I thought I had the ceiling T code in. I do have ceiling T. I do not have comparison operator with ceiling T. That is, which one is the ceiling T type? That is C1. 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 Okay, now I'm going to look at Bjorn's idea. What is the, well, start the stream from the beginning. That's what I have to say to anyone asking what the point of this is right now. Start the stream from the beginning. All right, this idea. Dennis Bjorn. Okay. Right. This was the suggestion. Oh, how many places did I make that mistake? You're going to compile? There you go. Thank you. Now, I have a templated constructor that can take any function pointer, and I want to do get of the decal type of p from the data, and I want to assign it to P. That gets rid of all of my constructors. And if I do a similar action, sorry, I'm just reading comments. Okay. So all of these getter functions, let's just get rid of those. And I want to create a very similar assignment operation. Oh, no, wait, that's my mistake. That should be just initialized with that value. And then here, this is an action ft reference operator assign. Not explicit. Oh. No return statement. constexpr function, return this. That gets rid of all of these operators. And then an assignment. Now, this should be better done with C++ 20's concepts. Let's call this a stepping stone at the moment. I always like to make code better every time I possibly can when I touch it. Get rid of that. Okay. There. Now the operations that we care about are neatly handled by a standard tuple. No, I don't need to protect against self-assignment. That is, in fact, why I templated it on this. If I had made it this, so this template will only match a free function pointer. So I don't have to worry about self-assignment. No problem. I'm eating a snack. Sorry for the crinkling. Oh. Right. I can't do that. I can't just initialize it with just one object. That's not going to work. But let us make sure that this thing is, in fact, default initialized with a bunch of null pointers. Stop that. Ooh, look at it fly. Excuse me. Oh, I took away my my defaulted operator equal. Again, that's a C++ 20 feature. What am I forgetting? Oh, const qualified, right? Which means I forgot it here too. And let's make this no discard. No discard. And okay, good. Why am I running in VMware? Because that's how I prefer to work. I have multiple virtual machines for various clients, various projects. It helps me keep everything sane for me. Those are warnings. I don't care about warnings right now. Ugh. Someday those warnings are gonna bite us. Subcommand failed and just stopped. Where's the error? Show me the errors. How do I filter these things? I don't know how to filter them. There's an error somewhere in here. Warning, warning, warning. Okay, this is a little silly. I need to suppress all warnings. What the heck? Where's the build failure? I don't care about the warnings right now. Ah, here we go. Move goobers. What the heck is a move goober? That's a floor move. See, now, part of the problem is that our compiler errors are going to be harder to understand now that we've used this templated type. But we know that we need a floor move T overload. And I am so very tempted to just add it right there. But I'm not going to right now. What in the world? Yank. Paste. Thank you. Floor move T. FM. That's a floor move. FM. This header file is touching a lot of other things. Every time I modify it, it's having to rebuild a fairly good part of the project. I know that there have been comments earlier like, oh, well, how does it compare? Like, what do we know what the results are and that kind of thing compared to the original C code. I will be doing an exhaustive look into that, just not today. I can use the build... What? I can use the Vim bindings in the build window? Really? What? I can. Gonna make all those type defs into a templated class as well, possibly. And yeah, you know, it's possible, Josh, that I am in fact trying to force type safety on a dynamic double dispatch that they did that ignores the type system. But here we are, we're gonna see what happens. Like I said, I wanted to see what I can move to constexpr. I wanted to see what I can reduce the amount of undefined or potentially undefined behavior in the code. Yeah, we're going to see what happens. So right here, what is this? TH, that's a thinker S. And this is something that takes an imobj t. All right. So that right there. Thinker cap. And then that's being cast into an imobj t. Now, interestingly, all it's doing is checking to see, is this the p-obj thinker? Now let's see. P imobj thinker. It is an actual function. That does take an object state. Well, this checks to see if the function is equal to that function pointer. But at no point is the function actually called in this code. I don't see the th or the mo placed anywhere. So this is part of the state machine, I guess. It's checking to see what the next state is. Something like that. I don't know. We'll see what happens. Yes, the shift does work with the bindings. I do use that also. But yeah, I could be using it. Yeah. Yes, I could be using it. That's a good point. Why in some places is it assigning to 1? In some places it's assigning to 0, and it's never ever checking for 1 or 0. This is making me nervous. It is actually making me nervous. Replace laser spot T. But you're not actually using it anywhere. That's magic numbers in code. See what happens. All right, this is the first actual function call that we've gotten to. So now we have to figure out how exactly to handle this. This is clearly checking to see if it is a valid function call before it tries to call it. And it is calling it with an imobject, yes. A player T, yes. and a PSP. Now, this is a little disingenuous because it's checking to see if this thing is a null pointer, but in the C code, it could have been any function assigned to it there, and it would have just called it. Yeah, the function pointer equals 1, 0, -1. It is bad news. We're gonna have to see if we ended up breaking something down the road, but I don't think we did. I don't think we did. What if we did this? Ooh, -2. Patch key interp. There's a lot of magic numbers in this code. I'm doing a wider search that's not just... I'm going to have to do a git diff and look for 100 plus matches and 53 files. Where's the regex button in here? Where's the regex button, actually? There it is. All right, it says that there's nowhere that we are comparing an action of any sort to -1. Are we comparing it to 0? No. Are we comparing it to 1? No. So who knows what that code was doing? Does make me nervous. Is this stream beginner friendly? It depends how much on your definition of beginner friendly. Yeah, there's only one function with 3 params. Well, there's only one function type with 3 params. I have an idea. Oh, they all have void return types. Yay! That helps. I did not need autocomplete in that code. Thank you very much. Why is that not compiling? Oh, the value is never used. So I don't need decal type auto. This is void. It's a void. Yeah, I got rid of the decal type auto. Try to ignore that right now. Okay, yeah, I got a call if. I agree. Let's do a call if. Let's do a call if right now because we don't know if there's other versions that we're going to actually want the return value from it. So call if, and that brings me to here, which should be something like call if. We'll see if we got this right if it compiles. Hey, it compiled. Neat. I have got to do something about formatting decisions at some point. What just happened here? This indentation is all wrong. It is all wrong. Okay. So, yeah, I like that. That worked. I didn't break the control flow. Did I? Oh, did I? Right, I did. So, I'm not actually gonna do that. I'm sorry, I just had to amuse myself for a minute. I don't actually like writing code like that. All right. Something like this is acceptable to me. Why am I not? Okay, yes, yes. Clang format, yes. Clang format. See, Clang format. It has Clang format. Why am I not using Control Shift L? First of all, I can't use Control Shift L in my editor. It's gonna blow up on me because of my various key bindings that I have set up. Secondly, I'm not doing it because I don't want to reformat the entire file. I need to know what I'm changing right now. If I reformat the entire file and something's broken, looking through the diffs is practically impossible. So I am only going to reformat bits where I can, where I need to. Then I'm going to reformat all the stuff. So yeah, I agree. I want to use Clang format, just not yet. Let's get this stuff working more in the direction that we want to. Then we'll use Clang format. You ever tried to look through diffs that have been reformatted? It's so incredibly painfully difficult. That's a strobe T. Oh, I do have a semicolon after the else. I'm back there now. All right, so everyone's saying Control Shift L. I have no idea what that just did. What did that do? All right, Control Shift I. Control Shift I. That did nothing. I can reformat existing code. I can do that. By the way, that was me using the double shift there. I do use it for lots of things, but I've not been assuming that, yeah, I've just been using the search window for most things here in this. Okay. What was my point? What was I getting to here? This is a new one that is using a, what is that? It is a strobe T. Strobe T. Yeah. I am being extraordinarily conservative with, I really am with reformatting the file because I just don't want so much stuff. But you're right. So I'm going to agree with everyone. I will do a flat cling format after I get this round of stuff compiling. How does that sound? Everyone agrees with that one. I will do that. Alt-Shift-L. Is that Alt-Shift-L? It should have just told me that. No, it's Control-Alt-L, which is why I'm not using it, because Control-Alt pops me out of my VM. I could reassign it. Boop. S1. That's getting exciting. Okay, let's... There. I missed a type def. Yeah, I'll do a commit just for reformatting. Yes, I always work in a VM. I have for over 10 years now. A lot of people ask about that. It is because I have several clients and I am often doing work for different people at the same time. Having VMs that allow me to easily figure out, you know, what client I'm working for at the moment, keep my work separated, personal, business, that kind of thing has been very helpful to me. I am self-employed. I have been for more than 10 years. The kind of things that I do, since I have you all on the listening here, is I teach C++, and that is my normal life. So this null pointer is going to be a little bit tricky with my templated. That is going to be a little bit tricky with that templated thing that is added. So yeah, I teach C++, I do training and whatever. So if anyone wants to have me at their company after the world opens back up again, you are free to have me at your company. You can contact me on my website or Twitter. It's pretty easy. So I can't just do that because it's not going to match on the template the correct way. All right, how do I want to do this? That's player T and PSP def T. See, that was what I was concerned about. The syntax is weird. It ends up becoming something like this to not be doing really weird things, and that's just ugly. Now, the upside being that our IDE is telling us all along here whether or not we did something reasonable. I guess I'm going to do that at the moment. Yeah, using the static cast. I just don't like it. I wish there was a better option. No, I don't think null pointer T would help me here. I need an actual null pointer. Lots of static cast. Probably gonna stop this in about 30 minutes wherever we are and pick it back up later. Hopefully we get somewhere interesting in a minute. That is a glow tee. A what? A glow tee? Action FG1. On the topic of, by the way, of my teaching, since I did mention that, I do, like I said, on-site training at companies. I know that there's at least one person in this chat channel who has been to my classes before. So if anyone wants to ask questions about that, feel free. Yeah, that build error, oh, nope. All right, cool. Aha. That's interesting. Again, interesting that it's specifically checking to see if ACP1 is true. Because in a C-style union, if any of the elements are assigned, this is going to return true. So if I want to keep with the original behavior, then I just need to check to see if any of these elements are assigned, right? That's what I need to do. Did I do that wrong? No, I didn't. Okay. I need a for each tuple element, which is shockingly difficult, actually. They're all different types, and I need to see if any of them are not equal to null pointer. Oh, hey, thanks for the $2. That's awesome. Who asked the question? Yes, I can do outside of US, no problem. Canada, I've not yet been to, but I can. I have no problem traveling outside the US. Europe has happened many times. Excuse me. Oh, what is the implementation of this? I need like a visit on tuple. There's something, right? What is it? Yeah, an index sequence and a fold. I don't have to go that complicated. I could just use, but I think there's a tool for this already. Isn't there? Tuple cat, for is tuple, make tuple, tuple tie, tuple get. I really thought that there's a invoke. There's a version of invoke. No. Invoke reason. No. Apply calls a function with a tuple of arguments. No, that unpacks the arguments and passes them to the function. That's not what I want. I am not pulling boost into this. Sorry, nope. Now I really want to know what it is I'm thinking of. I really thought that there was a version of invoke that took a tuple and called the same function with multiple versions. But now I'm gonna get, let's look in the functional header real quick. Function, bind, no, reference wrapper, no. Invoke, clearly not. All right, I'll just write one real quick. I saw the don't forget the const, by the way, thank you. Oh. Who said that? Alice Harbalek? I know that hat over the S does something that my American tongue can't do. But, yeah. Yeah, okay. So it is true that it contains something if this is not equal to an empty one of me. Ta-da! Goodness gracious, that seemed harder than it should have been. I'm on board with that. Yay. Yeah, compiler's thinking about that. I did get a valid question of why not use the not equals. And I didn't because partially I don't fully understand what this operator equals default gives me. So let's just go ahead and play with that and learn a little bit more about it. Is that going to compile? It does compile. So explicitly defaulting the operator equals must also give me the not equals operator? No, my assignment operator does not clear the other ones. I probably should do that. Let's do that right now. That would be easy to do. because I can just say, I can do what? Data equals ft of p dot data. Yep, that works. Yeah, explicit conversions to bools are a pain. And yeah, I'm just completely not familiar at all with these being able to default comparison operators. So that's cleaner, that's cleaner. We fixed this assignment operator. I think that is valid. We're just going to rely on the constructor to be able to do that. All right. That looks good to me. Now we're slowing down the entire build by pulling tuple in here because it's actually surprisingly expensive to compile, but this code is way more maintainable than it was, and we're getting more maintainable by the minute, I feel like. Just doing a quick mouse over on the type to make sure it's something reasonable. All right. Aha. Now we're getting to actual code that actually calls this stuff. And now we can really see what it's doing. And I'm going to take another quick 5-minute break. If you don't mind, I will be right back. All right, I'm back. So enjoy your dinner, Clears. All right, let's see what happens here. So I did a reinterpret cast to him. I'm obj t, but I have a thinker t. Theoretically, I can call it with just the thinker t. And if we have a function registered that expects a thinker t, then it should work, right? And that's dot call if. Thinker. Huh. We don't currently have any function registered that takes a thinker s. That is disappointing. Oops. Not strife. Maybe that's why I stopped using it. Not hexen. Maybe in Doom. Oh, that's got to be handy. Special val t. Thinker t. Doom. Think. Think t. Actually has its own type def already. Think t. That I don't have access to. Theoretically, I can get rid of the reinterpret cast because I'm trying to use strong type defs here. Or strong types. Thinker T, thinker cap. Incomplete type thinker T. Why? What did I do? Oh. That's weird. Oh, I'm in strife. Stop that. if, call if, call if. What did I do? Okay. Well, I think that's okay. Looking from the last comment from John. Oh, okay. Sorry. Yeah, I kind of wish I had pizza. Pizza's for dinner for me. All right, what's going on here? str is an action ft. All right, fine. I want to assign it from something that takes I remember this code. It's coming back to haunt me from 2 weeks ago. Oh. Wait a minute. What is happening here? Save reg p. So I'm calling that function, and it's returning a void pointer. And somehow it needs to be stored inside of my action ft. Now we have all of this written to handle function pointers. Now we've got something that has a void pointer and my precious action ft. And I need to get it back out. As a void pointer from my object. So yeah. Well, the game needs function pointers because that's how all of the actions are handled everywhere for everything. To not put too fine of a point of it on it here. That. Now, here's something I knew was probably coming at some point, so let's go ahead and write it. This is a conversion operator to whatever type is being asked for. No, 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 no. Nope, I'm not going to do that. I will do this, though. There. Okay. I don't like it, but we're at least deferring some of the undefined behavior. Oh, don't be silly. All right. I did mean thinker T. Thank you very much. I feel like I really don't expect this to work when I'm done. Really don't. I don't know. I want it to work. I'll just be surprised if it does. I feel like the probability that I broke something with those magic numbers or some pointer check somewhere at least we have code that we could debug now. I want any code. I just saw a question saying, is this even important to my code base? It seems that it's used for custom cutscenes and stuff. Yes, it is important. We want to maintain the behavior. Seems to be what we've all agreed to here. So that's weird. Only if the function is currently set to something, set it to something different. Huh. It's lots of assignments happening. That's all types that we know and understand now. Yeah, we definitely want to be able to load and save these things because I want to be able to load and save a replay a well-defined game so that I can compare the performance from one thing to another one. Willing to bet a beer that it will still work. Yes, I agree, Leslie. Lots of type punning and no test is difficult to accept, shall we say. Fix me no op. Come on now. I don't. Is that? Did I remove? No, I guess I didn't do anything. I just disabled it. I didn't remove it. Oh, close enough getting this to compile. I might stick with it. Lots of comparisons. Is this particular type of thinker? If it is, then do something. Seems so strange to me. Well, this code was extraordinarily fast and capable in its day, and it still is. It's amazing. You can run it on basically anything. I'll have to see what happens. I really like the fixes that we've made. I think they're good. I think the operator overloading, I think the reduction of type punning's good. I just don't see where these functions are being called yet. And that's what's really, I just don't understand and is making me nervous. So if, I try to raise a platform and a door goes up instead, we'll know what happened. All right, I compiled. Yeah, I compiled. Let's see, I already had... I swear I already had a window open with that in it. All right. Let's run it. Let's see what happens. This is... Yeah, all right. What did I just build? I just built Clang10 debug. No. Clang10 source CPP doom. Let's just double check that that was a binary just linked. It is in fact a binary that was just linked. So someone said they bet me a beer that it'll still work. I'll take a beer. Hit me up at a conference at some point. Let's see what happens. I'll buy you a beer, you buy me a beer. Not sure if the, yeah. I can't move. I broke something. Yeah, something did not go right. You're right, the bitmap for the HUD is showing. Oh. It just unsaved those for some reason. A lot is working. I just can't move. Although it's like I'm constantly moving. Yeah, it should definitely... Ooh, uh-oh. let's just verify the last version was working fine. Yeah. Build Crispy Doom. I'm just building the last version. All right, so this is back to Crispy Doom, which I just built. Now, what I found interesting is that I was leaving splotches. You're right, it's like time wasn't moving forward. That is definitely how it seemed. So all of these different actions, like a light flash and a fire flicker, these things, floor move, strobe, player, yeah. All right. Well, yep. I guess I'm gonna wrap it up. So that was what, 3 hours almost? It's Sea Lion. Well, right now I'm in NeoVim. All right. So yep, we'll wrap it up. Next time we'll come back. We'll see what happens. I'm gonna go eat lunch. Static casted the null pointer on the callf. Okay. Oh, what is going on? Okay. So, okay. I can't open the door. Okay. Yeah. Okay. I see something here now. All right, I'm gonna have to spend more time playing with that. Thanks. Well, that was John, right? That mentioned that. I should check that. No, it was Dennis again. Dennis. Yeah, Dennis. All right. So it kind of works now, but we can't. I gotta see something. So the HUD isn't being displayed at all, and it should be. So it is relying on all of these pointer functions actually ultimately being the same. It was relying on the... Maybe I solved the problem inside out. I shouldn't have added so many function overloads. Instead, I should have reduced the signatures of the functions that were being passed. I don't know. It's show FPS shows me 34 at the moment. And if I go back, that's a debug build running in a VM and with everything running. I don't know. I wouldn't put too much stock in that at the moment. Okay, all right. I'm gonna cut it off here. Clearly, there's something that we don't understand about the callback mechanism for all these things. Oh, the GitHub. All right, so for those of you who are still sticking around, it is going to be actually let me make a couple of commits real quick. No, it's cpp-doom. All right, that's the repository. All right, I am out of here, everyone. So yeah, thanks for joining me for this, and I am definitely have had a full day now of doing this. So I'll catch everyone later. Thanks a lot. Bye.